Okay, Rupak, you can start.
First of all, thank you everyone for joining this session. Thanks for me. Thanks for having me in this session. About myself, I am an undergraduate who is passionate about cybersecurity and also an active open source contributor. And I am also the current lead of OWASP student chapter ID Patna. So here we will be discussing how not to code and how not to invite hacker to hack their website. So so I will demonstrate some common mistakes that a web developer makes with PyGoat. So what is our purpose of this meet? The purpose is to give developers and testers a platform for learning how to test application and code securely. The PyGoat is written in Python, specifically in Django framework, backend framework, and uses uh, it also has web application vulnerabilities such as XSS, SQLi. Uh, those vulnerabilities are mainly based on OWASP top from 2017 and both 21, and there are MITRE 25 MITRE top 25 vulnerabilities also. PyGoat also PyGoat also provide a section where you may the source code, identify what the error is and that lead to the vulnerabilities, and make adjustment to secure it. It also provides a free platform for everyone, so that specifically students can learn about all the vulnerabilities. So let me show how you can get this. So this is the official repo, and you can clone this repository and run in your machines. Also, there are Docker image also for easy installation. So if you go down the readme.md, so there are three methods of running this repository. The easiest one is the Docker container. We just have to install Docker and this command docker pull pygoat/pygoat. It will pull the latest Docker image of the PyGoat and it will run in our local host. Then we can run this repository in our machine also. For that, first we have to clone this repository. Then I have already cloned this repository, so we'll show how to run. There should be a virtual environment. Make sure to create a one and activate that virtual environment. Then there is a requirement.txt. So install all the dependencies with this command pip install -txt. It should install all the requirements. Then we are good to go. So our main project is in this PyGoat folder. So let's go to this folder, and all we have to do is Python manage.py run server and 0:8000. This is optional. If you want to expose our IP publicly, so we can include this 0:. Otherwise, it will run in default 8000 code. Before that, let me open the code base in VS Code. This is it. So I already have logged in, so don't show me the login option, but it by default show this login page. We can log in with Google, and we can register with PyGoat also. So I have an account, so I'm logging with my credential. So this is the welcome page, and let me describe some basic overview of the PyGoat. So there are multiple sections. The first one is OWASP top 10 from 2021 version. Here is 10 vulnerability list. Then we have Sans 25 vulnerabilities top 25. Then we have Mitra top 25, and we have archive OWASP top 10 from 2017. Also, this challenges section don't have currently don't have any challenges. So today's focus will be OWASP top 10 from 2021. Let's get started with broken access control. So first we have broken access control. A broken access control vulnerability is a type of security flaw that is allows an unauthorized user access to user to access restricted resources. By exploiting this vulnerability, attacker can bypass standard security procedure and gain unauthorized access to sensitive information systems. So this is pretty dangerous thing, and some common mistakes can trigger this kind of vulnerabilities. Let me demonstrate how. There are three labs. I will go with the lab 3. So let me check. So in lab 3, two user credential is given. One is admin credential, and the other one is regular user credentials. So let me log in with the admin credential first, just to see how it looks. Admin. And we have logged in, and there is a secret button. I think, yep. And this is the secret page. So let me move to light mode. I think you can see now. So this is supposed to be a secret information only meant to available for the uh, admin. Now let's back to normal user. So here we can't see the option for the secret. So this means the secret page was only meant for the admin. So but here we can do like this slash secret. Sorry. Uh, I think, what was the URL? So I am logged in with the regular user, and again we can access this uh, check. So So I have logged in with the regular user, but still I can access this page, the page which meant for the admin only, and the regular user don't have the these options, but I can still access this page. So this page was unrestricted, and proper authorization not followed in this section. So even the option was given to the admin only, but normal user can access due to the specific authorization system. So we should avoid this kind of coding issues. Next, we have cryptographic failure. So the primary cause of sensitive data exposure is cryptographic failure. So some of examples are hard-coded passwords, broken or risky crypto algorithms, and insufficient entropys are among all the enumeration covered. The first step is to define the data protection requirement of data in transit and at rest. Passwords, then credit card numbers, health record, personal informations, and business secrets. For example, various policies, etc. required requires additional safeguards, particularly if the data is subject to privacy law, such as EU General Data Protection Regulation. So we should encrypt those kind of data so that to protect our users' privacy. So there are three labs. Uh, I think one thing forgot to mention, like in 2021, three new vulnerability came into this top 10 list. This is insecure design, uh, then software and data integrity failures, and server-side request forgery. And some of them have a pretty good, like broken access control. It was in fifth position. Now it is in first position. And this cryptographic failure also uh, came to second position from third position. So in lab one, some user credential is given. So some hacker previously performed a SQL injection and attacked the database and managed to get the database dump for user table. So a hacker got the password hash for an user. So can we log in with the hash? Let's see. Obviously not, but let's see. Yes. Uh, we can't password login with the hash. Hashing is a good thing, but this thing is not as secure as we imagine. Like there are various hashing algorithms, and we can rate the hashing algorithms on the basis of security. And for this kind of hash, we can just say this hash is weak just by looking. Let me demonstrate how we can break this hash. So for a given hash, we can first we have to identify the hash. So there are online tools to identify this hash identifier. So this hash identifier predict this is MD5. Also, they give the uh, uh, password for this hash. So this is admin1234. So the fact is, uh, we can't the actual data from a hash, but this what these tools does, they collects commonly used passwords and hash them and put them in a database. And whenever we have a hash, we can search the hash in their database, and they give this the password. So this is very easy password, and though they have hashed the password, we can still get the actual data. So let me log in with the password we get from those. As we see, we can successfully logged in with the logged in as an admin. Another thing I have to mention, like MD5 is a very weak hash, should not be used to hash passwords. Next, we have another same kind of problem, but in this lab, I think the hash is pretty long. Let me check which kind of hash this is also. So the possible algorithm could be SHA-256, pretty stronger than the MD5, and it barely have hash collision. So it should not be that much easy to decrypt this password. But if the password is very commonly used password, then there must be some database where we can find this hash. So this is still not secure. The the recommended way of hashing a password is using strong algorithms like Argon, or we can use salting for creating different hash for the same password. This should be used for hashing crucial data. Then we have in lab 3, we have the user credential for this page. And we have to log in as admin and get the secret. So let's log in with the user credential. So we have successfully logged in as a normal user, and there was not any hash given. So what, how we can log in into the admin? So let's check the hint. Okay. So let's check the code itself, how the code is written. This is lab 3 from cryptographic failure. If you want to see the code, you can copy the this URL, relative URL. Go to this folder, introduction, then search for url.py. Then you can search the URL path here. So this one, and this is the function vis.cryptofailure lab3. Control click navigates to the actual function implementation. So here we can see if the request method is get, then it checks for a cookie. Then it checks if the cookie is expired or not. Then if the cookie is from admin, then it shows the admin page. And if the cookie is from normal user, it shows normal user page. And if the request is post, that is we are login, so it sets the cookie. And as we can see, this cookie is setting clear text cookie. So let me show where the cookie is setting. So this is the cookie, which name is cookie and value is user, then the expiry date. So here we can see the clear text cookie is there, and if we change this to admin and go back, so it says that congratulations, you have successfully logged in as an administrator. So what is happening here? Uh, the cookie is not hashed. So any normal user can tamper with the cookie itself and modify the cookie data. And the server take the data from the cookie, checks if the user is admin, then showing the admin page. So this is a portion where uh, authen- encryption should used, but it uh, not used. So these are the mitigation where which should be followed so to avoid this kind of failures. Then we move to the next section, injection. So injection is a broad category where the main concept is some raw data is passing through the backend without proper validation. In SQL injection, some raw data is passing in SQL query where it executes in database and dumps some either some result. Same for command injection. Command injection, some raw data not properly verified, it goes to the our CMD or any shell that's running, and it executes something malicious. So there are left for SQL injection, then command injection and template injection. Let me show the template injection one. So for those who don't know what is a template, so a template is a usable or dynamic HTML code, and a template injection helps us compile the template. So this Django itself is in a template. So as we can see, this never this there are many pages in this PyGoat itself, and for every page we don't have to rewrite the sidebar every time. We make component and just import this component in a base URL, and we extend the base template with this inner content. So this is what templating does. It reduces much time and human resource. So this lab uses Django's default template engine. So there are some blogs. Oh, sad. Let me write a blog. Okay. So which one? Hello world. So we can post blogs and it uh, saves our blogs. So this is fine. I am writing HTML code. The problem is we can do something like this. Uh, I guess this is the right keyword. Oh, let's Google for it. Yep. So this is the right keyword, and there are many templates by the way, and not for Django. There is a brief blog about template injection. Uh, there is tweak for PHP, plug.js for Node.js, EVR for Ruby, and lots more. So all these languages use templating. So let me demonstrate what template specific keywords it does. So I'm just posting this blog with curly percentage debug. Let me post, and this is what it prints. All the uh, these are the all the internal data we can see from here. So it can be blocked from the configuration, but yes, it exists. We can also do XSS attack also. So here is an example for the XSS attack. This thing. So as you can see, some script is executed. So obviously this is not safe. Next we have insecure design. So the what insecure design is like. The main problem in this category is not the code structure or how the code is written, but the problem begins in the much earlier stage where in planning stage basically. So we differentiate between design flaws and implementation defects for a reason. They have different root causes in remediation. So let me demonstrate what with an example. So this is a demo website where a user can claim up to 5 tickets, and here it will show all the tickets for that user, and we can submit one ticket and we watch some movie or something. Let's see. So let me claim 3 tickets. So I have claimed 3 tickets. Now let me claim 5 more tickets, which is not possible. Yep. So the code doesn't have any security flaws. The code is secure itself. So all the checks are done properly. So I think I can claim 2 more tickets. So let me claim that all. Yes. So now I have 5 tickets. Now let me let's watch some movie. So what it says like wait until all tickets are sold. 55 tickets left. So actually I have to wait for all the tickets are sold, and this is okay. But uh, what I can do, I can create more 11 account, and I can redeem all the 55 tickets, and this way no one can watch the movie. Only uh, I will be the person watching movie in a theater. So here the main problem is not the code, the planning. They have some planning issue. So some redemption in this case would be some proper um, some proper logic so that one user can't create multiple accounts, and that's it. There are some other examples also. Due to time constraint, let's move to the next topic. That is security misconfiguration. So security misconfiguration can happen at any level of an application, including the project configuration or the OS configuration or server configuration, network configuration, or anything it could be. So in this case, let's discuss about project configuration only. So we have here 3 lab. Let me demonstrate lab 2 details. So uh, this Django have one feature called debug equal to true. This is for development purpose because we need to see what is happening behind if an error is occurring. So, but in production we should uh, disable this debug with debug equal to false. Let's see what happens if somebody by mistake don't do this, and the debug equal to true is uh, debug is equal to true. So here we can we have to page that triggers a 500 error. So let's create some error. So I can navigate to some random page which does not exist, and it will dump some error. This is because of debug equal to true. If debug was false, then it won't show this URL patterns. Now I think I can see all the URL patterns, and from here there is a URL pattern called 500 error. Let's go to that page. Yes. So this creates an 500 error, and here is some data. Like here is HTTP CSRF token, session ID, my system details, my GPU configuration, etc. is also dumping. So this is clear leaking of data, private data. This is also my profile ID, then session ID, my path, and all the things. My hardware configuration also. So uh, this is a crucial thing to we need to stop. Next, we have vulnerable and outdated component. So in a full-fledged project, we need multiple. We mainly use some framework or any language stack, and we use multiple components from other. We import them or include them, whatever. So whatever component we are using, there is a maintainer who is maintaining this component, and they are continuously upgrading their components to newer version, and of course if a version have some security vulnerabilities, and they so fix those vulnerabilities and create a new release. Now let's see if we what happens if we use older version. So there are two labs. I'll demonstrate lab 2. So this page, what does it takes an image as an input, then we can do something like convert some math expression. It will generate some image on the basis of this expression. Let me demonstrate. So this is the actual image, and this is the image generated by the math expression I have just imported. Let's try again. Uh, so this is another image generated. So how can we exploit this, and where the developer can make mistake making this website? Let's view the code. So this is checking for authentication. This is top level authentication. Let's ignore this thing. And in the post section, it is requesting a file, the image file I am giving. Then it imports a function string. Then it is opening the image file, separating the RGB layers. Then it is applying the function I am giving input using this function image math.eval, and returning the output. So here one thing we should notice that if function string is the variable that is user input, and it is directly passed in this function. So this should not be done. Some validator must be used whenever we take input from an user. Now, how to exploit this? Let's see. So the hint is this uh, this page uses below 8.000. So let's search for below 8.000 vulnerabilities. So I have already opened the tab. This is uh, below official documentation, and there are documentation for all the releases 3.9.3 to 2.70. So this page uses this version 8.0000, this version. Uh, let's see what new in 9.000. There isn't a tab for security. So, and here is the all the problems they fixed in this version that occurs in the previous versions, like JPG image plugins, and here is the main thing, image mathable. So there is a problem in this module itself, not in our code, but the module have some problem. This image mathable can execute can do remote execution. So this is a keyword like execute exit. So let me show you how what happens if I do this. Before you can see like this server is running. Now look what happens when I'm clicking the submit button. So as you can see, as server error occurred. So you can, I think you can see like this is not the standard error the Django throws. This is a different kind of error. If it was not Django, like Django is far more web secure, and if it was like normal Python HTTP server, it should have died by this. So what it does, it stops the current process. But Django have some inbuilt security, so it won't work for Django. But there is some pretty good amount of injuries. So next, let's move to the next vulnerability. We have identification and authentication failures. So authentication is a crucial step for in any application. We have to authenticate all the user which who are using the application, and there are very various security measures and standards we should take. So there are three left in this section. So I will demonstrate the left three. Uh, let's assume a scenario where X access his account, and uh, before leaving he logs out from his account, and you did not say okay. So what it does, this okay, sorry. So okay, so let grab some credential. So this is user one, and this hash one. Let's log in first. Many time what happens, we log in our friend's account, friend's machine, and after logging in we do our job, and then we log out. But what this website does, these have some defective mechanism in the logout in the logout system. So if we log out, then it's log out, then I think it looks fine, but there is some problem. Let me show what. So if the request method is get, let me demonstrate one another thing. User one, password, okay, URL, actual lab details. And if we go to this page again, it won't show me the login form. It will directly fetch the user because it is setting some cookie. Let me show where is the cookie. So I guess this is the cookie session ID for this one maybe. So whenever I send a get request, it fetch the cookie. If the cookie is valid, then it shows the user data, uh, and the cookie is saved in the database. Now let's see the code. Sorry. So if the request method is get, then it fetch the cookie, and session it looks for the session. It is the cookie is stored in the database, so it looks for the cookie in the database. If it found a session, then return the username, uh, or accept this renders the default form. Then if the request method is post, then a token is generated. Nice. Then username is taken, password is hashed, and checked if the password is correct. Okay, that's also seems right. Now check the logout function. Yep. So this is the logout function, where if username and password is not given, then the logout is called, and what it does, it sets the cookie to none. Now there is a problem, like when the successful login is happening, then they uh, create a session data. They save the cookie in the database itself, but when they're logging out, then they only deleting the cookie from the user side only. They are not removing the cookie from database. So what can happen, like uh, cookie stealing can be happening, like a user will be logged in into this website, and some malware will be stealing those cookies and using those cookies, and hacker can get access to their accounts because the cookie is not deleted from this database, and older cookie can access this user too. So let's say a user logins in login 5 times in 5 different machines, and he also logs out, but this creates five cookie, and those all those five cookies are active. Anybody can use any one of those cookie and access his account. So this is a wrong authentication step, uh, and we should ensure that whatever we are creating on this authentication and identification, we should it should be secure, because it involves a user's privacy and security also. Here is hey user. Uh, is my screen visible? Can someone reply? Hello.
Yes, hello.
Yeah.
Wait a moment.
Is my screen visible? Okay, let me continue. In this page, there is download direct download page, and if we click this link, it also downloads. But this time the file is fake1.txt. But uh, I'm downloading the both file from the same page, but the file is different. So what could be the problem here? The problem is this thing. Uh, this this text field, and some hacker performed some XSS attack and changed the file URL and gave me this link. So instead of text file, it could be some executable binary, and if I have run those binary, it could have harmed my device. So as we can see in the bottom here, the there is some script. Sorry, here. Yes. So in this case, what should be happen? Like it should check for the checksum of that file, and so that a file cannot be changed in a web page. There are also all mitigation how to prevent this kind of vulnerabilities. Like there are all the points you can read from PyGoat. And next we have insufficient logging and monitoring. So logging is
Uh,
an important. Hello.
can you start your share screen?
Oh yeah, sorry,
Because
sorry.
you forget it.
Screen is not visible.
Okay, okay. No worry.
Is my screen visible? I guess yes.
Yes, I see your screen.
Oh, thank you. Okay, so let's continue. So mm, this is insufficient and logging and monitoring. So logging is an important step uh, for backtracing an attack. So exploitation of insufficient logging and monitoring is the bedrock of nearly every major incident. The attacker can rely on the lack of monitoring, and they can hamper your devices and servers, and you can't know who is doing all these stuffs. So logging is an important step, but there are also rules how to log and what should we log. Like in log, there should not be any sensitive informations like passwords or any other credentials, and uh, logs are meant for only internal people, but it should not be public. It shouldn't be any public URL. It should not be publicly available. It is only for the developers and internal people who are maintaining the project. So here is two file. So as this is easy. So so is here is some URL that is leaking the log, which we should not do. This is done mistakenly, I guess, but we should not do this because user can take crucial information about some file structure or any other thing and get some advantage. In lab 2, there is an active logging where logging is performed on every this step. Okay, so whenever I login the wrong username or password, but a log is saved on this entry. Let me show the log. So this is the log and this is the log, and this is the uh, entry where I put the wrong password. So this is quite good. Like it didn't show my password, even it was log wrong. Okay. So what we can do here, like we can take username, password, anything, or we can do this thing, copy some random text, paste here, and run. Let's see what happens in the log file. Uh, so here the all the data is also in the log file also, which is unexpected. So it won't be easy to if I put random data in the log file. It won't be easy for the insider people to uh, debug the information. So so what is happening here also, like they are taking the name and without verifying the parameter, they are putting the name in the database log file. So uh, yes, so anyone can put some random data and a large amount of data, and the log file can be exploded, or it can hamper the performance of the server also. And it can if we craft some fake log also, we can also craft some fake log with new lines characters, and it will create lots of fake log, and it will be harder to further check for the problem. So this we should take some security measures to avoid these problems. Last but not the least, we have server-side request forgery, and this is a newest addition to WASP top 10. So server-side request forgery occurs whenever a web application is fetching a remote source without validating the user supplied URL. So a, a malicious user requests in server some data, and the malicious user what request is like request some other server for the data, and the middle server fetches the data from the third server. And like we can the main use of this attack is internal mm, internal data collection. Like I don't have the uh, direct access to this data, but the server does. Then we can ask the server, give me the data, and server will give. So let me demonstrate first. So the next page shows some blog. Let's do it. So there are four blog, one, three, four. So this looks fine, but if we check the code, this is every time I'm clicking in this buttons, it is sending some post request, and mm, it is taking the file name of this file as an input, which is extremely bad. This is hard coded, but for dynamic blogs where user can create blog and they can view their blog, it may be an scenario where they take input of the blog location, which blog they have to fetch, and they read the location and output the blog. So uh, Here the application is fetching requesting for file name, and it opens directly the file name with extending with the directory, and it is returning the data. So let's check the HTML. So as we can see, this is a form. This button is a form where there is some hidden input, the sales rep token itself, and then there is some hidden value with the value of template, lab, SSR, blog. So this is complete file path where the blog is. So this is very we can change the file path and access some other code. Let's access some other code. We can change this value to .b, I guess. And if we click the blog one now, then I think, let me check the folder. So these are the blogs they are fetching from. There is some secret.txt. Let try to access this secret.txt from here. So the path was like outside the blog folder. So it should be secrets, sorry, secret.txt. So this is the content of the secret.txt. Let us verify. Yes. So though the secret.txt was not listed in this block options, we can still use that file and through this uh, through with changing this file URL. So I don't have the direct access to this text file, but I have indirect access through server side request forgery. So this is extremely dangerous, and we can also uh, search for the some crucial files like .env file in the in a base directory, and we can basically in this URL I can put any relative path, and I can fetch any other files. So that was it, and there is another lab too, by the way. So I want to be solving that, and there is some code discussion. So this is a part where you can this is like quiz or something, and here you can tick mark which code have some problem, and you can play with the code. You can modify the code and check if it is what uh, if the security is improved or not. I think some other lab also have this feature, like yes, yes. So identification and authentication failure also have this uh, code lab where you can play with the code. Here is the code itself. You can modify the code and try to fix the broken code and evaluate for checking purpose. So and there are also other portion like Sans top 25 vulnerabilities and Maitre top 25 vulnerabilities. But I think out of time, so I will be wrapping up the presentation. So that's it. Uh, Thank you everyone for attending this session. I'm open to any questions from you.
Okay, thank you, Rupa, for your presentation and your demo about PyGoat. For everyone or participant, if you have any question, you can text in the in chat. Any question you can message in the chat. We can wait for your question, or you can directly ask in here. Any question? Okay, Rupak. I think they are clear. Maybe we can stop this meeting. Nah, that's it.
Uh,
One question
I,
from Harapan.
yes, sir. So, is this scanning application paid? Yeah, this is completely open source, and you are free to use, and you can obviously can contribute to this application also. This is not a scanning application, by the way. This is a learning application. Uh, what type of applicant scan? No, no, sorry, sorry. So this is not a scanning application. This is a learning platform for all the beginners, developer, and cyber security enthusiasts. So the main focus of this application is so that they become familiar with the common web application, web vulnerabilities, and which common code mistakes one should not do. So that's all about it.
Is there any question again? We can open for two question. Okay, Rupak, I think there's no question to you. You can close this session. If
Thank you, sir. Thank you.
yes, if you is there any question, you can email me. I take my email to in chat adet.putra@owas.org.
Uh,
Okay, maybe you can share your email to Rupak. Maybe the
yeah,
participant
yeah.
want
I'm
like
sharing. I'm
maybe
sharing my email also.
okay. Okay, thank you all. Happy uh, good good night. See you in next meeting. Okay, thank you all. Sit. Thank you.